So AI is pretty much everywhere, right? But have you ever stopped to wonder how a machine actually learns anything? I mean, it's not magic. It really comes down to three main strategies. And today, we're going to break down exactly what those are.
All right, so what even is machine learning? At its heart, it's all about algorithms that let computers learn from data. The key here is they do it without you having to explicitly program every single little step. So instead of us writing a million rules, we just let the machine find its own patterns. It learns from experience, kind of like we do, just on a massive, super fast scale.
Okay, so that leads to a really big question, right? If a machine is learning from data, well, what are the different ways it can learn? Are there different teaching styles for computers? The answer is a huge yes, and trust me, understanding these is the key to getting a handle on AI. First up, we've got the most common, and maybe the most intuitive method, learning with a teacher. In the AI world, we call this supervised learning.
Just think about how you might have studied back in school with flashcards. It's exactly like that. The machine gets an input, say a picture of a cat, and then it's told the correct answer, the label, which is the word cat. It does this over and over with a whole labeled data set. The goal? To learn the connection so well that eventually it can spot a cat in a photo it's never ever seen before.
Now, supervised learning is really good at two main jobs. The first is what we call classification. This is all about sorting things. A classic example? Is this email spam or not spam? It's a yes or no question. The second job is regression, and that's about predicting a number. Like, what will this house sell for in 6 months? So you can think of it this way. One sorts, the other predicts a value. And believe me, you are using this learning style all day, every day. It's the magic behind your email's spam filter. It's how your phone uses facial recognition to unlock. It's even in the systems that try to forecast weather patterns or predict stock prices. Basically, anytime you've got a bunch of historical data where you already know the right answers, supervised learning is probably the go-to tool for the job. Okay, so supervised learning is awesome, but it has a big dependency. That answer key, right? The labeled data. But what happens when you don't have one? What if you're just staring at a giant mountain of raw information with no labels, no answers, nothing? How in the world can a machine learn from that?
Well, that exact problem brings us to our second method, learning on its own. We call this unsupervised learning. And yeah, it's pretty much like throwing the machine into the deep end of the data pool and just saying, hey, figure it out.
The best way to think about this is to picture a detective walking into a room full of clues, but with zero instructions. With unsupervised learning, there's no answer key to check against. The algorithm's only mission is to sift through all that data, all the clues, and just find hidden structures, find patterns. It's not a student with a textbook, it's an explorer.
So what kind of patterns is our little data detective looking for? Well, for one, it finds clusters. This is like grouping similar customers together based on what they buy, which is super useful for marketing. It also finds associations, discovering which products people tend to buy together. And, maybe most importantly, it finds anomalies, spotting something weird, like a credit card transaction that just doesn't fit any of the normal patterns. That's how fraud gets flagged.
There's this famous, almost legendary real-world example of this, the beer and diapers case. It sounds totally bizarre, but an analysis of shopping data uncovered this hidden pattern. Turns out, when a supermarket put beer right next to the diapers, sales for both went up. Now, a human would probably never think of that connection, but the data showed it loud and clear. That's the real power of unsupervised learning, finding those connections we'd completely miss.
All right, so we've covered learning with an answer key and learning without one. But what if there's no data set at all? Not a single file? What if all you have is an environment to interact with? This brings us to our third and maybe most dynamic method, learning from mistakes. We call this reinforcement learning. This one is probably the easiest to wrap your head around because it's so close to how we and even animals learn. There's no big book of data to pore over. Instead, you have an agent, think of a robot or a character in a video game, and it learns through pure trial and error. It tries something, sees what happens, and then adjusts its strategy for next time. The whole process is this constant feedback loop. It goes like this. 1. The agent takes an action in its environment. 2. The environment responds, giving it some feedback. 3. That feedback is either a reward, hey, that was a good move, or a penalty, nope, don't do that again. And 4. The agent updates its internal strategy, always trying to figure out how to get the most rewards in the long run. It's all about maximizing that positive feedback. And this is the incredible technology that powers AIs that can beat the world's best players at super complex games like chess and Go. It's absolutely fundamental for advanced robotics, for self-driving cars that have to make split-second decisions, and for systems that optimize high-stakes financial trading. Basically, it shines in any dynamic situation where the best path forward has to be discovered through raw experience.
So, there you have it. Learning with a teacher, learning on its own, and learning from mistakes. But here's the thing. These aren't rivals. They're not competing with each other. The real magic of machine learning happens when you think of these as a versatile toolkit. You can even combine them to solve really complex problems.
For example, what do you do when you have a massive data set, but labeling every single piece of it would cost a fortune and take forever? Well, that's where a cool hybrid approach called semi-supervised learning comes into play. You manually label just a tiny bit of the data, and the algorithm uses those few examples as a starting point, as a guide, to help it make sense of the vast, unlabeled rest. It's a really smart, efficient way to get the best of both worlds.
Okay, let's wrap this all up with a quick cheat sheet. First, you've got supervised learning. It needs labeled data, and its goal is to predict outputs. Think spam detection. Then there's unsupervised. It uses unlabeled data to find hidden patterns. Think grouping customers together. Third, reinforcement learning. It learns from reward feedback to find the best actions, perfect for robotics and games. And finally, that hybrid, semi-supervised, which uses partial labels to combine learning types. Each one is a powerful tool, just designed for a different kind of job. From your spam filter to self-driving cars, these learning methods are already changing our world in massive ways. So I'm going to leave you with a question to chew on. Now that you know how they all work, which one do you think is having the biggest impact right now? And more importantly, which one do you think is truly going to define our future?